Double and half angle formulas. Where do they come from and how do we use them? All right. So first, let's talk about the one that was actually in the homework, number 35, which said that the sine of 2x comes from the sine of x plus x, which is sine of x cosine of x plus sine of x cosine of x. And so the formula, the identity for the sine of 2x is 2 sine of x cosine of x. You need that. Take it down.
Mr. Ronco, I know this is like beginning stuff, but like I thought we said it's like the opposite. So like if it's in the parentheses it's a plus, you go minus.
That's true in a cosine.
Cosine. Okay, I think I got a couple wrong on the homework.
Well, here's the deal. Here's how you remember. If it was the opposite, the sine of 2x would be 0. Right?
Oh yeah, because they just cancel out.
Yeah. Right. So that's one way where you can just, I mean, that's how I remember. Yeah. Like I said, I don't memorize anything. Okay. Ferris, did you actually create a hashtag ban Herminio? That's not nice. Okay. Now, the next one, which is actually, well, this, by the way, this is it. This is the only thing you got. Okay, that's it for the double angle formula. Cosine's a different story. Cosine of 2x, you go through the same process, but now it's cosine, x plus x. Cosine, cosine, sine, sine. And so we get this formula. Now, this one is a lot cooler because it's got sine squareds and cosine squareds in it. And in fact, if we take that nugget of information and use in conjunction with it the other identities that we learned the other day, which were that the cosine squared of x is equal to 1 minus sine squared of x. If we take this formula and take this piece of information and substitute, we get that the cosine of 2x is equal to 1 minus the sine squared of x minus sine squared of x. And dropping parentheses and combining like terms gives me another formula. Now, we could have done the exact same thing, but instead using the other Pythagorean identity, and substituting into sine squared of x, and now we get this. Oh, sorry. So we have 3 for the cosine of 2x, but we only have 1 for the sine of 2x. Make sure you copy those down. In fact, later on when we get to do calculus, these two formulas pop up in a very interesting and useful place, and we will need them. Give me a thumbs up when you've got all that copied, please. Still got one or two people copying, so. All right. Okay. Now let's go ahead and do tangent just because we can. So the tangent, actually, how about this? You all do tangent. There's only one formula for it, so do it on your own. Okay. Did we all get that, hopefully? Okay. So those are our double angle formulas. All right. So let's do some. All right. So here's the first type of problem that you're going to have to be able to do. You're going to have to turn this into, like, I don't want the cosine of 3x. I just want the cosine of x. So we're going to have to break apart cosine of 3x and chip away and churn and burn so that at the very end of the day, all you have are cosines. Okay. Now, that tells me that of the three forms for the cosine of 2x, one of them is a lot more interesting to us than the others because only one of them, this guy, contains only cosines. The others contain sines. And, yes, I can turn the sines back into cosines, but why? Okay. So do you want to try it on your own? You wanted me to just do it? Okay.
Mr. Ronco, the camera, oh, it's focusing.
No, it's not. It's lying. Okay, I'm usually not a violent person, but that was kind of fun. And it worked. Okay. That was mildly cathartic. All right. So cosine of 2x. So cosine minus sine. Okay. Now the first thing that I'm going to do to this is I'm going to get rid of my sines because I know I don't want them. There's not a heck of a lot I can do with sine of 2x. There's only one identity for it. And now putting that in there, now I'm going to get rid of that sine squared x because I really don't want it. Now I'm feeling okay, except that I got this cosine of 2x, so I'm going to go ahead and substitute that guy right now. And that's 2 cosine squared x minus 1 cosine of x. And I'm just going to go ahead and multiply out this guy. I'm going to distribute him. And now I'm just going to combine my like terms. And you're done. Okay. All right. Now, okay. Here's a good problem type that we need to look at. Okay. Oh, I love this. Okay. So here's the way we have to play the game. First of all, we have to know where we're living. We're living between 180 and 270 degrees. So we're living in the third quadrant. We've got a triangle with some sort of reference angle that looks sort of like that. Now, the cotangent is the reciprocal of tangent. So tangent of theta is 3/4. And since tangent is opposite over adjacent, but we have to remember that this is a negative y and a negative x. So we have to put both of those being negative. And that would be fine because remember, -3 over -4 is still 3/4. Now, by looking at it and realizing you're dealing with the Pythagorean triple, there you go. Now, in order to find the sine of 2 theta, we use the identity for the sine of 2 theta, which is 2 sine of theta cosine of theta. And the sine of that theta would be -3 over 5. And the cosine of that theta would be -4 over 5. So we get 24 over 25. We good? Thumbs? Okay. So just breaking it down, first figure out what your triangle looks like. Use the given information to help build your diagram, fill in the rest of your diagram, and then use an identity to find other stuff. So using this same triangle, would you find for me the cosine of 2 theta? So there are, believe it or not, 3 ways of solving this problem. In fact, actually, you know, actually there are 4 ways of solving this problem. Okay. So let's go ahead and use some of our formulas. I'm just going to redraw the pictures so that I don't have to go flipping back to it every time. So the cosine of 2 theta is cosine squared theta minus sine squared theta. By the way, did anybody get an answer? Put it in the private chat if you have. Oh boy. We have lots of variations. We have many permutations of wrong. We've got some right answers. Okay, let's do it. Cosine squared. Cosine squared would be -4/5 squared minus sine squared, which would be -3/5 squared. 16/25 minus 9/25, which is 7/25. That's one way of doing it. You could have also done 2 cosine squared theta minus 1. 2 -4/5 squared minus 1. 2 times 16/25 minus 1. 32/25 minus 25/25 is 7/25. You would do the same thing with sine, or you could have said, you know what, Ronco, I don't even want to bother with that because you already told me what the sine of 2 theta was. Because, remember, cosine squared of any angle is 1. And since you already told me that sine squared, that sine of 2 theta was 24/25, which is 25 squared minus 24 squared all over 25 squared. And so 25 squared is 625. 24 is 576. 25, the square root of 25 squared is 25. 625 minus 576 is 49. Seven over 25. That's another way to do it. Yeah, sine errors will kill you. Okay. Give you one, and I'm not going to help you. The sine of theta is -4/5. And I have the following information. You are in that interval. Find me this the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. Put your answer in braces with commas. Put all three in the chat at one time, please.
You're muted.
Oh, fantastic. That was exciting. I love talking to myself. I wondered why nobody gave me thumbs up when I asked for thumbs. Okay, moving on. Going back, here are your three values. The tangent of 2 theta, you could have saved yourself a lot of trouble by just realizing the tangent was sine over cosine and doing your...
Mr. Ronco, we don't see the, it's like blurry.
Oh, I love this. First you can't hear me, then you can't see me. Oh, I just give up. I'm gonna kill you, you know that. Just letting you know. Just letting you know. Okay. Thanks. I actually just said that on camera. Wonderful. Moving on, people. Okay, so now half angle formulas. Okay, so the way to find the half angle formulas is to go to our cosine of 2 theta formula. And let's keep it in terms of cosine. Now, what we want to do is we want to find, we want to say let x equal to theta. So now theta is equal to x over 2. So with this little relationship, taking this and plugging it back into here, I get the cosine of x is equal to 2 cosine squared of x over 2 minus 1. Now, this helps us because now we can solve for the cosine and the cosine of x over 2, and we'll have a half angle identity. So adding 1, dividing by 2, gives me my cosine squared of x over 2. Now, square rooting that creates an interesting point. Because when we square root that, we have to consider that the cosine takes on multiple values, both positive and negative. So we have to consider where our angle is to determine whether or not my new angle, my half angle, is a positive half angle or a negative half angle. Okay. So for example, before I go any further, let's say I have an angle living in the second quadrant. And I take that angle and I chop it in half. Now, my new angle lives in the first quadrant. So even though the cosine of this angle is a negative number here, the cosine of the half angle would be a positive on this side. Let me ask you this question. Where would the angle have to be in order for it to be that the cosine of the half angle would be negative? what quadrant would produce an angle that has a negative cosine of, that would produce a negative sign right here? That's right, Karen. It would have to be in the third or the fourth quadrant. Because if I'm in the third or the fourth quadrant, and I cut my angle in half, I will have an angle that lives in the second quadrant. So this half angle would be small, would be negative as well. And then you would use the negative sign. And if it lived in the fourth quadrant, and I cut it in half, I would be having a negative half angle as well. So you're going to have to do a little bit of mental stretching to ask yourself, should I be giving the positive or the negative value here? All right, now let's do the same process to find the sine of theta over 2. So using the cosine of 2 theta, giving me 1 minus 2 sine squared of theta, and using my substitution, x is theta over 2. Or, yeah. No. The other way. X is equal to 2 theta. Now, yeah, that would give me quadruple angles. So x over 2 is equal to theta. So now the cosine of x, 1 minus 2 sine squared x over 2. And now we solve for the sine of x over 2. So 2 sine squared x over 2 is equal to 1 minus the cosine of x. And now dividing by 2 and square rooting. Again, I see a plus or minus. But now, instead of having a plus sign in my numerator under my radical, I have a minus sign. And again, you'll have to make judgment calls as to where the sign will produce a positive or negative result. We could sit here and divine intervals, but it's probably easiest if you just imagine where the picture is and cut the angle in half and then make calls. All right. But I would say, unless, pretty much any angle between the, you have to be less than 360 and you'll still have a positive value. Okay, because even at 359 degrees, cut that in half, you're still above the x-axis. So you're almost always going to have a positive value for this. Okay. Unless you're dealing with angles that are greater than 360 degrees, and then all bets are off. Okay. Now, to get the tangent, we use the reality that the sine of x over 2 over the cosine of x over 2 and now a fraction of square roots is the square root of a fraction. which simplifies nicely. To that. Questions before we go forward? Okay. All right, let me see if I can find some good. Oh my God, you're gonna kill me. I'm gonna kill you. Death and destruction. Yep. No, I don't want to go that. All right. So let's try this one. Theta is in quadrant 4. And the sine of theta, oh, we already did that one. The sine of theta is -8/17. Find the tangent of theta over 2. Mhm. Anybody get an answer? Definitely working too hard. Oh no. Wait. Wait. Start from there. Throw that out. Start from there. Simplify that. Guys, are we drowning?
Yeah.
So the question was, how do you know what the signs are? Okay, well, first, by the way, yeah, you guys were just working too darn hard. Who got here? Forget about the sign out in front. Who got there? Give me a thumbs up if you got there. Just get rid of your denominators, guys. You're going to see me do this thing a million times. You distribute that 17, it kills that denominator, and boom, you're done. Kills that denominator, boom, you're done. Simplify 3 over 32, reduces to 1 over 16, square root of 16 is 4. Now, as far as the signs go, I'm trying to get GeoGebra to work here, but it's being a bit of a drag on this machine for some reason. My Java is out of date. I can try and show you what I mean now. All right, let me see if I can get GeoGebra to work. Of course not. All right, let's see if you can just screen share and see what I'm talking about. All right, so here's the deal. I got an angle C, and I'm cutting it in half. Yeah, you can't. You have to come over here. Can you guys see the circle that I'm working with here?
Yeah.
Right. So here's the deal. If we're talking about angle C, well, I'll just get rid of this for a second. Let's just delete it. Okay. You can see? Yes, sir. All right. So if I have this angle, and if I'm living in the, oh, what the heck? What I want is the point of intersection. So if I'm dealing with a, if I'm looking at the half angle, as long as I'm living in this, if I'm in the first quadrant, the half angle is in the first quadrant. If I'm in the second quadrant, the half angle is in the first quadrant until I get to 180 degrees, and now I'm at pi over 2. Now, of course, it has to flip on me, so that's really exciting. Stop. I hate the apps. God. Whoever decided to create a thing called an app is a... So now, oh, please forget it. I think y'all get the point. Getting a little tired of this. So this is why. This is why I spend time and energy on equipment. Okay, now if I'm in the third quadrant, my half angle at point D is in the second quadrant. And I'm still going to be in the second quadrant all the way until I get to 0 again, or 360. Okay, so depending upon where you are, you're going to have to ask yourself, all right, what does cutting the angle in half look like? All right. And so taking an angle and cutting it in half, you know, if my angle is right here, that's theta. Cutting it in half would be right here. Oh, you can't see that either. Okay, so that would be theta over 2. So it's going to take a little bit of geometric reasoning for you to think about it, but it's not the end of the universe. Okay. All right. So what I'm going to do is I'm going to give you some problems to work on, some things to chew on. Tomorrow, what I'm probably going to go over are a couple of more formulas, maybe some geometric interpretation problems. And probably give you a hefty assignment to do because the next week is the week before spring break. Take a look at your, tell me what the 24th looks like on your calendars. Does anybody have any major assignments due on the 24th? Anybody have anything absolutely deathly critical on the 24th? All right, so let's plan on a quiz on the 24th. Okay. That being said, ladies and gentlemen, I do believe we are done. You have yourself a Merry Christmas and a Happy New Year. And I will send out the homework assignment for you. It won't be that big because it's only going to be on half and double angles. I'll send that out to you via email. But please, yes, the homework would be due tomorrow. It'll be small. Just some practice problems. Okay? Yeah, I could stay after for a minute if anybody has any questions. All right, everyone. Go out and play in the snow.
Thank you. Bye.
Bye.
See y'all.
Thank you.
Sure, buddy. Speak to me, brother.
Okay, Mr. Ronco, so just to make sure, so if this was it, how would you, if you cut it in half, where would you go?
Okay.
I'm not sure if you get
I can see
so
that.
kind of like the same one we did, right? Actually, it is the same problem that we did. Mr.
So,
Ronco, can you, oh, okay.
you see it?
I don't see anything.
Really?
It just says plan on a quiz on the 24th.
All right, I'm gonna move you into the. I'm gonna move. Hold on. I'm gonna move you into the waiting room and pull you right back.
Okay.
Hold on.
Oh, I see it now.
You do? Okay, good.
Yep.
All right. So the half angle
Bus 755, students will ride bus 214 in lane A. Bus 256, students will ride bus 746.
You'd be right there.
C. And bus 759, students will ride bus 112 in lane C.
It would be a straight line through there.
Oh, okay. So when you cut it in half, you take, okay, so you cut it, so it becomes, okay, so you cut it in half. So it's half of it, and then it's also on the other side.
Yeah, because
Like it's flipped.
so if I'm here, see you, boss. I'm not gonna kill you. No, it's really quite all right. All right, so whether I'm talking about this angle on this side or this angle on that side, half of this is gonna be the same as half of that. Here, look at
Okay.
the graph. Hold on. It's half and half no matter what. You see?
Yeah.
The arc CB is cut in half, and the arc CDB is cut in half.
Yeah. Okay.
Yeah.
Okay. So wouldn't matter.
No, it doesn't. So sometimes it's easier probably to visualize it the other way, but
Okay. I see. I see. Okay.
cool.
Okay. Hopefully, I'll understand it when I see it on a problem.
Yeah, you're gonna have to do some practice. I mean, actually, it does require a little bit of stretching your mathematical visual brain a bit, which is not a bad thing. Okay. All right.
Okay.
You have a great day, sir.
You too. Thank you for staying after.
Sure, no problem.